Hello wonderful person, this is Anton, and today we're going to discuss some of the more unusual discoveries when it comes to planet Earth. But specifically discoveries in regards to Earth's gravity and a somewhat unusual gravitational anomaly that was just discovered by accident in one of the recent studies. And normally these gravitational anomalies reveal secrets hidden deep beneath the surface that traditional surface geology could never uncover. And so today we're going to discuss some of these recent discoveries and compare them to some of the similar discoveries from the moon, and of course discuss this most fundamental phenomenon or this force on the planet, gravity. But first let's briefly discuss how we know all of this and how this is usually studied. Because a lot of these incredible discoveries could not be possible without specific satellite missions. And I think this one right here is probably the most important and the most famous of them all. This is a pair of NASA satellites referred to as GRACE, Gravity Recovery and Climate Experiment, that's been going on for at least 2 decades. And the point of this mission is pretty simple: mapping the entire planet and trying to identify various irregularities when it comes to various values for surface gravity. And so here the point is to try to discover the actual gravity value compared to what's expected or what's predicted based on a theoretically perfectly smooth Earth model. Because these gravitational anomalies do exist everywhere, and that's because none of the objects in the solar system, including our own planet, are perfectly spherical or uniform. And because gravity is directly proportional to mass, and also since different materials inside the planet will usually have different density, they're going to create slightly different gravitational pull, and they're going to produce slightly different values for gravity in every location on the planet. Now, the actual differences are very minuscule, but they're still there. And in order to measure all of this, scientists came up with this very brilliant mission. It essentially uses twin spacecraft orbiting extremely close to one another, and they orbit in such a way that they can actually see each other, projecting lasers as you can see in this picture. And so here, as the first satellite passes over a certain area, if it detects slightly stronger gravity, it's actually going to speed up momentarily, which will change the distance between satellites and will be visible because of these very precise laser observations. And really because of, well, lasers. They're just such an incredible tool for super precise measurements. And so here, by precisely measuring changing distances, researchers can then start mapping the gravity of every single point these satellites pass over, which is of course where you usually get something like this. Now this is extremely exaggerated, but this essentially shows you slight field anomalies measured in milligauss. And for this to make sense, we have to understand what these milligauss are. Milligauss is essentially a measurement of gravitational change, with the Earth's standard gravity being approximately 980 gauss, or 980,000 milligauss. In case you're wondering, gal here stands for Galileo. And 1 gal represents 1 centimeter per second squared. And so you can see that some of the values are approximately 50 milligal, which is almost nothing compared to 980,000 that represents the average on the planet. But nevertheless, these values are quite specific and quite significant. And as you can see in certain regions on the planet, there are unusual anomalies, specifically positive anomalies and negative anomalies. Now, positive anomalies usually occur where the measured gravity is just a little bit stronger, and this normally indicates the presence of dense subsurface material, like for example some kind of a metallic ore, or maybe dense oceanic crust. And so here this can actually be used in detecting new mining materials, or in trying to map the invisible plate tectonics. So this is essentially useful for both mining industries and geologists. And the negative anomalies, which are obviously produced by slightly lower gravity, usually represent massive basins filled with light sedimentary rock, or potentially unusually thick continental crust. So this is what you see right there in Africa, which makes it a vital tool for planetary exploration, or technically even lunar exploration, because something very similar was also done on the moon. And so, for example, for mining, when scientists detect some kind of a negative anomaly, this can help delineate sedimentary basins, which very often hold oil and gas reserves, because these rocks are usually much less dense compared to surrounding basement rock. Whereas the positive anomalies can reveal extremely rich iron deposits or any other dense metal. But for geologists or scientists trying to understand the planet, this is also how we can study plate tectonics and even the structure underneath, such as the crust and the mantle. Because here gravity maps are perfect for revealing faults, folds, or structures inside the planet and discovering boundaries between Earth's crust and the denser mantle below. And so essentially this is one of the most important tools for geological sciences. But it's recently also become super important for studying climatic changes. Because here over the years, GRACE became essential for what's known as time-variable gravity data. essentially changes in gravity fields that seem to happen over months or years, and which seem to be the result of redistribution of water on the surface. And this includes tracking groundwater, melting glaciers, and changes in the sea level as well. So this is a crucial tool for hydrology and climate forecasting, which is what it's basically been used for the past few years. And so when you hear about any studies involving changes in water distribution, that's usually where this data comes from. And the data here is super accurate, because here even millimeter changes are usually observable and visible to these satellites. But this is where we come to today's mystery and this somewhat bizarre observation. Because for decades, scientists believed that a lot of these time-variable gravity signals would probably be coming from various surface processes such as water, ice, or maybe atmospheric mass shifts. Which is of course what you can actually see in here, based on these previous maps made over the years. But this is where things get bizarre, because a recent analysis that came out just a few days ago uncovered some really bizarre data that didn't make sense. A very strange event that originated far deeper than anyone predicted, and seems to have happened between 2006 and 2008. So essentially this happened over a decade ago, but somehow was missed until now. And the peak for this event apparently happened in January of 2007. And this was an anomalous, large-scale gravity signal that seemed to have emerged over the eastern Atlantic Ocean. This is essentially what you see in these pictures. And interestingly enough, this was not a small event. It seems to have spanned approximately 7,000 kilometers or about 5,000 miles, which reflected a significant mass redistribution. And here researchers spent a lot of time comparing the observations against every known process, and it basically confused them for a very long time. For example, models shifting water, or any kind of atmospheric changes, just did not make any sense. This signal could not be explained by either water or atmosphere, because it was just too powerful, and the amount of water required to produce this would be just unrealistic. And this forced the scientists to come up with a different hypothesis and a different explanation. Here they had to go down thousands of kilometers below the surface, down to what's known as D layer, a layer located near the boundary between the mantle and the outer liquid core. And here at a depth of 3,000 kilometers, they possibly discovered the source. And here the evidence points at something that's not expected at all. An extremely rapid density change deep within the Earth's solid interior, and very likely resulting from some kind of a mineral phase transition that happened in just 2 years. Or basically, there was some kind of a chunk of stuff that then transitioned from one phase to the other, kind of like water changing into ice, which basically changed its density, and that affected the gravity. And this study is so detailed that they even identified what most likely changed. The material in question is the mineral referred to as brigmanite, also sometimes referred to as a silicate perovskite. And it just so happens that under extreme pressures and under extreme temperatures, which we obviously do find inside the planet, this mineral can change its crystalline structure from perovskite to post-perovskite, which sort of resembles this. And this change usually involves a dramatic density increase, which can obviously affect gravitational measurements. And since in this case the temperature generally determines the depth where this occurs, here it was most likely triggered by some kind of a vertical motion, for example material rising from the base of the mantle, which possibly caused the transformation, with all of this happening extremely fast. So once again, kind of imagine ice melting and becoming water, just because it went from somewhere much colder to somewhere much warmer. But interestingly, the movement of this material was extremely close to another geological mystery, African Large Low Shear Velocity Province, LLSVP. The bizarre structures inside the planet that we discussed in some of the previous videos in the description, whose origin is still not certain, but that obviously influenced the planet in certain ways. And so here this change caused a rapid mass redistribution, very likely affecting the African LLSVP and making it shift a little bit. And what's even more interesting is that apparently this event also coincided with something else, a somewhat unrelated anomaly in the Earth's magnetic field. So here this event spatially and temporarily coincided with the geomagnetic jerk, or basically a sudden rapid change in the variation of the magnetic field, which seems to have happened around the same time. And so this connection suggests that these deep mantle mass redistributions may directly influence the fluid core motion that generates the magnetic field as well. And though it's not entirely clear how all this connects yet, these incredible new discoveries will most likely lead to some really important explanations about what happens inside planet Earth. But right now, researchers believe that this phase change very likely caused the topography inside the planet to change just enough to shift things by about 12 centimeters every 2 years, which is what was observed in 2007 and why we saw so many anomalies during this year. And these discoveries are also important because they essentially offer us a unique window into the rapid dynamics inside our own planet, proving that the solid mantle, even at its base, can undergo some relatively fast structural shifts that only take a few months at most, and shifts that can even impact observations in gravitational fields and even affect the magnetic field as well. But here, just for funsies, let's maybe also take a look at our partner, the Moon, because for many decades the Moon has also been studied quite thoroughly and has also been mapped by very similar missions. And that's because, unlike Earth, the Moon is relatively solid and relatively stable, and so here various anomalies usually tell us a little bit more about the ancient events that shaped this object. And for decades, scientists noticed something really strange. A lot of spacecraft orbiting the Moon, especially over large impact craters, would routinely veer off course. And so having a permanent and stable orbit around the Moon has always been extremely difficult. And so it turns out that compared to planet Earth, the Moon's gravity field is incredibly bumpy, which becomes pretty obvious when you look at this map or when you compare the anomalies to our own planet. Here, a lot of the gravitational anomalies are usually 6 to even 10 times more powerful. And so today a lot of these mass concentrations are referred to as mascons, with the mysteries surrounding their formation once again largely resolved by similar twin missions, in this case referred to as GRAIL. The satellites that kinda look like this. GRAIL stands for Gravity Recovery and Interior Laboratory. And so this GRAIL data show that a lot of these mascons don't just create strong centers of gravity, they often appear with a very unusual bullseye pattern. A center of strong positive gravity surrounded by alternating rings of weaker and stronger gravities. And the reason why the Moon seems to have this is its violent past. So basically a lot of these large asteroid impacts that the Moon experienced over the years seems to have produced most of these bizarre anomalies. But turns out that these bullseye patterns only formed under specific conditions, when the asteroid struck much thinner crust, and specifically because this allows the denser material from the underlying mantle to then rise toward the surface, concentrating mass near the surface and creating these bizarre mascons. But the areas of the Moon with much thicker crust resisted these formations, with impacts not resulting in any of these mascons or these bullseyes. And so by comparing the gravity anomalies on Earth and the Moon, it really shows us how fundamentally different a lot of planets and moons seem to be. And so on the Moon, the gravity anomalies are primarily fossilized geological records. A lot of them are billions of years old and have not changed much for a long time. And they essentially reflect ancient cataclysmic impacts that left permanent mass concentrations trapped beneath the surface. Actually, most of them occurred during the late heavy bombardment over 3 billion years ago. But on Earth, gravity anomalies are both static and dynamic and allow us to study so much more. For example, these static anomalies help us map stable geological structures like mineral deposits or even understand plate tectonics, whereas the dynamic parts help us understand the changes in the water and atmospheric pressures, or even learn about these bizarre structures underneath the planet. And so these are definitely super important studies, and even help us challenge the traditional view about the deep mantle and the locations near the core. Even though we always thought these were extremely slow processes, this study based on the observations from 2007 tells us otherwise. And so this is not just academic, this is about building a comprehensive model of planetary behavior, and about understanding somewhat surprising and still poorly understood workings of planet Earth. And as always, you can learn about all of this in a study by Charlotte Anton and the team you see on the screen. And so until future discoveries about our own planet, that's pretty much all I wanted to mention. Thank you for watching, subscribe, come back tomorrow to learn something else, support the channel on Patreon where you can find additional videos without any ads and can DM it directly, or by joining the channel membership that grants you early access and a few more things. Alternatively, you can also buy the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.